Good day, good day, good day. You're welcome to Math Made Easy by Jacob. So, my presentation today will be on fundamental rules of logarithms. Fundamental rules of logarithms. So, so before I continue, I will start with the definition of logarithm. Now, before you talk about logarithm, you need to make reference to what we call index, which is indices. The logarithm of a number n to base a is the power to which a must be raised to obtain n. So the power at which the index at which n is raised to obtain the value, the index at which a is raised to obtain the value of n is what we call uh, indices. So it's called logarithm. So this establishes the fact that every logarithms has an indices. That is, all logarithms have indices. So to every logarithmic equation, there exists a corresponding index notation. So if you have that at the back of my mind, that every indices has a whole logarithm, because the power to which a must be raised to obtain n. For example, if I have log um, n base a, so the power to which a must be raised to obtain the value of n is what we call logarithms. So in the course of this presentation, I'm going to take us through the fundamental rules of logarithm, this the fundamental laws of, logarithms. So I have seven logarithms, seven standard logarithms. So this presentation is presented by Matt Made Easy by Jacob. So I would urge you to subscribe to my channel and also like this video and also forward it. Now, condition for logarithms. So these are the condition for logarithm. Base b must be greater than 0. So my base must always be greater than 0, and my base must not be equals to 1. So these are things we need to note. For a logarithm can satisfy a particular law, that means my base must be greater than 0 and my base must not be equals to 1. Another one is on the argument. M, which is the log, and n, which is also the log, must always be greater than 0. So if they are not greater than 0, that means the law, the condition, and the law of logarithm may not take place, because the logarithm of 0 to any base is what? Is 0, and the logarithm of 1 to any base is what? Is 0. Logs are exponentials, so you should know that logarithm are exponents rather. That's what I explained at the first slide, that I said every logarithm has their indices. So exponent means power, which is also known as the index. So every logarithm has indices. Now look at this log here, where we have log n base b, so equals x. So the exponent of log n base b is b raised to power s equals n. So this is the exponent of log n plus b. So the exponent is the initial equation. These are the exponential function in logarithms. in the indices. So this logarithm has these indices. So continue. So move to the product rule of logarithm. That is, when you have two logarithms of equal bases, look at this, they have equal bases. They have base b, logarithm of equal bases. Once they are added, the result will be the product of the two logarithms to their common base. Now see the common base, which is b. So the result of this logarithm that are added, the result will be the product m times n is b to their common base. That is that for the product rule of logarithm. Now we have the other one, which is the quotient rule of logarithm. That is when two logarithms of equal bases are subtracted. I mean that we subtract log m base b from log m base b. The result will be equals to, that is, the one subtracted is used to divide the other. I mean that we use m to divide, we use an n to divide m. So that means by subtraction change to what we call division to their common base, which is base b. So these are very, very important. Before you can actually be able to obtain a solution to a given logarithm, one needs to understand the concept of these laws very well. Subtraction to what? Division. That's when you are giving logarithm of equal bases. So if their bases are not equal, that means logarithm loss or logarithm may not be satisfied, not be satisfied. So I'll move to the next one. Now to the next slide, I have the product rule. This product rule, that is, when logarithm is raised to a certain power, the power is used to multiply the logarithm itself. Now look at my log here. I'm having log m raised to power log m raised to power x. That's the power index. So I'll use this power to multiply the logarithm, which is log m. This is log m base n. So this power come down to multiply the logarithm. So you see what we have here. So whenever you have a logarithm in this form, you follow this procedure to simplify it. Now we move to the next one, which is zero rule. Now the logarithm of 1 to any base is 0. So log 1 to base 100 is 0, log 1 to base 200 it is 0, log 1 to base 3000 it is 0. So logarithm of 1 to any base is 0. Now when you look at the normal calculator you will use, science calculator you use, it's already in base 10. That's natural log. So when you just press your log 1, you know that it will be equals to 0. So in any base at all, logarithm of 1 to any base is what? 0. So move to the next one, which is identity rule. Now this law is also known as logarithm to its own base. Now the logarithm of any number to its own base is 1. That is log 1 base 1 is 1, log 10 base 10 is 1, and you see that log b base b it is 1. So the logarithm of any base, logarithm of any number to its own base, that is when your log and your base are identical, the result is always 1. So move to the next law, which is called the inverse property of logarithm. The inverse property of logarithm. Now before we talk about the inverse property of logarithm, you should try as much as possible to recall from the power law that I explained the other time. That is the index law of logarithm. As I said, when a logarithm is raised to a certain power, the logarithm is raised to a certain power, the power is used to multiply the logarithm. That's what first thing you should know, you should recall from the second slide, and also from the fourth slide rather, and also you need to recall the logarithm to its own base. Now look at log b base b. So we already know that will give us 1. So if this s is coming to the other side to multiply the logarithm itself from the power law, so that means we are going to have s log b base b, and we already know that log b base b is 1. That will be x times 1. That's why we have x. So anytime you have a logarithm in this form, you should know that the result is always going to be just the power. So just going to be the power. So if I have log 3 raised to power 2 base 3, I should know that my answer will be what? Will be 2. So this is very, very simple and straightforward. So when you use these laws, it will rightly is you'll be able to attempt any questions on laws of logarithm. Now we move to the next one, which is inverse properties of exponent. Now this one is trying to explain when um, a number is raised to a log and the number that serve as the base and the base of the logarithm are equal, the result is always just the log. So that what it's trying to tell us, that whenever a number is raised, whenever you raise uh, a log on a number that has equal base with the base of the with the base of the log, that means the answer is always 1. The answer is always just the log rather. So that means if I have 2 raised to power log 3 base 2, 2 raised to power log 3 base 2, my result is just 3. So you should note this very, very well. My result is just 3. So we'll move to the next slide, where we have change of base law. Now this change of base is applicable. Now before I talk about change of base law, this inverse property of exponents, we can actually um, let me just tip in what we call uh, power of the base law. There are some cases that your base will have the power. So when your base is having the power, instead of using the power to multiply the logarithm itself from the power law that I explained earlier,